Hello students, welcome to the course on Hydrology EVE 301 offered to civil engineering students at College of Science and Technology. I am Kirtan Adhikari, faculty at CST. See you in the course. Today we shall start with Introduction to Hydrology. Hydrology is the science that deals with occurrence, circulation and distribution of water of the earth and earth's atmosphere. Engineering hydrology is a part of hydrology that concern with engineering applications that deals with planning, design and operation of engineering projects for the control and use of water. It also associates with estimation of water resources for planning and management. The harness of water for agriculture, industrial, urban development and hydropower's development also comes in engineering hydrology. Study of processes such as precipitation, runoff, evaporation, and their interaction to manage water resource efficiently. Study of the problems such as floods and droughts and to formulate strategy to combat them also tends to get it's focused in engineering hydrology. Hydrology is further divided into many branches such as hydrometry. It is a branch of hydrology that deals with measurement of different components of hydrologic cycle. Likewise, there is ecohydrology, hydrogeology, hydroinformatics. Hydroinformatics, in fact, deals with adaptation of information technology or computer technology in hydrology for water resource management. And there are many more. You can find more on this topic on the link provided below. As mentioned previously, hydrology is associated with many other professions. For example, urban resource manager would be focused on studying urban hydrology. Likewise, geologist would be interested in understanding the interaction of water with soil and such study is known as hydrogeology. This figure shows the link between hydrology and other science field. It is just a representation and everything is not everything is not discussed in this particular image. It is just for you to understand that hydrology is not a stand-alone subject, but it has its association with many other fields. Now coming to scope of hydrology for an engineer, it is primarily for computation and estimation of water at various phases of hydrologic cycle. As an engineer, we must be in a position to find or calculate minimum flows that are expected to occur at a place, minimum reservoir capacity to be fixed to meet all water demand from a multi-purpose reservoir, minimum flows which can occur during any dry season, regulation of flood through hydraulic structure, environmental impact of hydrologic structure, study of groundwater potential and its uses. To summarize everything, it enables civil engineer to perform qualitative and quantitative evaluation of hydrologic processes. Coming to the hydrologic cycle, hydrologic cycle is the central focus of hydrology. It is a schematic representation of occurrence, distribution, and process involved in circulation of water in its three phases, that is, solid, liquid, and gases on the earth. As shown in the figure, water evaporates from the ocean and land surfaces to become a part of atmosphere. Water evaporates from the ocean and from the land surfaces and it gets into atmosphere. The water vapor is transported and lifted in the atmosphere until it condenses and precipitates. The precipitation either starts to flow over the land or infiltrates into the ground. Infiltrates into the ground through a soil and subsurface and it contributes to subsurface flow. Overland flow discharges into river, and then it starts to flow downstream. The water, the infiltrated water may percolate deep into the underground to recharge underground, and at times it tends to come out to the surface as springs, and finally it also drains to the rivers. Likewise, the process continues. Likewise, the process continues, and the main driving factor for this cycle is solar energy. As an engineer, we are supposed to estimate water in various processes of the hydrologic cycle. Hydrologic cycle, as discussed earlier, was for entire globe. To learn about the processes, a smaller region or catchment is considered. This catchment is a subsystem in the earth. By identifying a system or the catchment, the various processes of hydrologic cycle can be studied at a smaller scale. For example, this is a catchment. Amount of precipitation that occurs over the catchment can be measured, and total runoff that is generated can also be measured at this outlet point. From this input and output, we can understand and analyze the system. Moreover, the hydrologic phenomena are extremely complex and may never be fully understood. However, in the absence of perfect knowledge, they might be represented in a simplified way by means of a system concept. Mathematically, the input function, which is in the form of pulse, is converted or transformed to a graphical function in terms of outlet that depends upon time, and catchment is acts as an operator. So this operator operates on the input function to convert it into output function. So this is what is known as system concept. Various processes of hydrologic cycle is mentioned with plus or minus sign indicating whether it adds water into the system or withdraws water from the catchment. We know that total mass of water in a system is constant. Based on this, we can formulate a basic governing equation for the catchment. And this governing equation is known as hydrologic equation or water budget equation, which states that inflow minus outflow is equal to change in storage of the catchment. And with the help of this equation, we can estimate the various amount of water in various processes. Processes that adds water into the system are given the plus sign, and processes that withdraws water from the system are given the minus sign. Like precipitation adds water to the catchment, so it's giving plus, whereas runoff, the groundwater evaporation or evapotranspiration tends to remove water from the system, so we give it negative. And when you and the inflow minus outflow gives us the change in storage, and storage can be of three types. Water may be stored in a form of surface water like in dams or reservoirs, or soil moisture, or stored as groundwater. Moving on it, I have delineated the catchment of Omchu using QGIS. If you wish to carry out research in hydrology, then I recommend you to learn this software. You can follow the link. You can follow this link. It's a YouTube video to learn how to delineate catchment in QGIS. You can see that this is a catchment of Omchu, and this is the place, this is the CST, and you can also see the Phuntsholing Thimphu highway here. And if I give you a reference of Sorchen region, so this region is a Sorchen. So whatever the rainfall occurs over the Sorchen, it finally drains into Omchu, and it gets finally it goes to the Omchu river, and then through Omchu it goes to Amochu. So if you consider catchment of Amochu as a system, then catchment of Omchu become a subsystem. Likewise, if you consider entire earth as the system, then catchment of Amochu becomes a subsystem. And further, if you go into deeper, then catchment of Omchu becomes again one more level of down, that is a subsystem of the entire globe. So by breaking things bigger parts into smaller chunks, it enables us to do hydrologic analysis. Now let's talk about the water resources in the earth. It is estimated that about 97.5% of water is present in ocean as salt water. Remaining 2.5% is fresh water, out of which the major chunk, that is 68.9%, is as a glacier or permanent snow cover, which is not available for human consumption, and 30.8% out of this 2.5% is available as groundwater or soil moisture, and only remaining 0.3% is available as lake or river storage. And in Bhutan, if you want to get any hydrometeorological data, you may want to contact the National Center for Hydrology and Meteorology, Thimphu. You can visit their webpage. And here are the list of few softwares which is necessary to do any hydrologic analysis. I've divided into four categories. Category 1 is the geographical information system, which is the utmost. Without knowing this, it becomes nearly impossible to do any hydrologic analysis. And category 4, Python is a tool, that is a programming tool. It enables you to do many data analysis. If you're interested in hydrology, you must learn few softwares, and I recommend QGIS and Python to begin with. With this, I would like to end my presentation. Thank you. Okay, now let's do a simple numerical on the topic using our water budget equation. The question states, estimate the constant rate of withdrawal from a 1375 hectare reservoir in a month of 30 days, during which the reservoir level dropped by 0.75 meter in spite of an average inflow into the reservoir of 0.5 million meter cube per day. During the month, an average seepage loss from the reservoir was 2.5 centimeter, and total precipitation on the reservoir was 18.5 centimeter, and total evaporation was 9.5 centimeter. First thing that you must have noticed now is unit. It has all mixed unit. So to apply mathematical equation, one thing we have to understand is the unit must be consistent, and to make it consistent, usually we play with volume. So to apply water budget equation, which is inflow volume minus outflow volume is change in storage, we have to identify each process is whether it is inflow or outflow. So to begin with, you first convert area into meter square, which is hectares to meter square is into 10 to the power 4. Likewise, days, 30 days is okay. The drop is 0.75 meter, that's also fine. Now inflow is given 0.5 million meter cube per day, so that you have to convert into a volume. So to convert this into volume, you multiply with the time, then you get time is 30 days, so you get 15 million meter cube in 30 days. Likewise, seepage is given as meter, 2.5 centimeter, which you can convert it as 0.025 meter, multiplied by the area of the reservoir will give you the volume, total volume of water that has seepage. Now likewise, you can convert precipitation and evaporation, and only thing that we don't know in this equation is O, that is outflow. So from this equation you can find O, and if you, this is the total volume of outflow, and to find the constant rate of withdrawal, you just divide by the time, that is in 30 days. So if you convert, divide it by so many seconds in 30 days, you will get this constant rate of withdrawal, that is meter cube per second. I have also given a simple program. It uses a different library known as SymPy. It is a CAS system, computer algebraic system. It has the ability to solve equation. So instead of giving the giving the values, if you give equation, it tends to solve the equation and it will give back the equation in terms of unknown. So the solution is O minus this much value is equal to 0. So from here I just got the value. So if you're interested, you can also code it yourself. So this ends our first unit. Thank you.